We use z-scores to compare values that are on two different scales. For example, ACT scores and SAT scores. Have you ever wondered how they know that if you made maybe a 23 on the ACT that what your equivalent score is on the SAT? They do that by finding the z-score values, and then you can compare them. So we have an example here, and on this one is we're just going to find what our z-score is, and then we're going to decide, is our z-score above or below the mean. So we have a formula for z. The z-score is the data value, and we denote the data value using an x. We're going to subtract the mean and then divide by the standard deviation. So that's the formula in symbols. What I like to do on these problems is to write down everything we're given. So it says the test scores on the math test have a mean of 58 and a standard deviation of 11. Andrea scored 85 on a test, so her data value is 85. That should not have a bar on top. How many standard deviations from the mean is a score of 85, and is the score above or below the mean? So finding the z-score, we'll have the data value, subtract the mean, and divide by the standard deviation. This gives us a z-score of 2.45. Notice here I use 2 decimal places. We're always going to use 2 decimals when we're talking about z-score. So that's another rounding rule you just need to remember, 2 decimal places with z-scores. Now, that tells us that we are 2.45 standard deviations from the mean. Okay? 2.45 standard deviations from the mean. But is that above or below the mean? When it's positive, that means that we are above the mean, and negative means that we are below the mean. Since 2.45 is positive, it's above the mean. Now on the next slide, we'll look at comparing two values. So we have student A. So let's write down our information. Student A takes a test and scores a 65. So the data value is a 65. The test is designed so that the population parameters are mu equal to 50 and sigma equal to 10. So they're giving you population parameters here instead of sample statistics. So we're going to be using the symbol for mean, mu, which is 50, and sigma for standard deviation, which is 10. Now student B takes a different test and scores a 29. Its mean, mu, is 20, and standard deviation is 5. Which student has the better score? What we need to do here is find the z-score for student A and student B. Then we'll compare those two z-scores. The one with the highest z-score has the highest test score because they're further away from the mean. So, finding the z-scores, ZA, the data value minus the mean divided by the standard deviation, and that gives us a value of 1.5. Now, the z-score for student B, the data value minus the mean divided by the standard deviation. You get 1.8. Comparing these two values, we see that 1.8 is larger than 1.5. Not by much, but it is a little bit larger. Therefore, student B has the better test score. So we write our answer, student B has the better test score. On the next one, we're going to be comparing test scores again. So why don't you pause the video, work this problem, and then unpause it and see the solution. Okay, example, which is better? A score of 92 on a test with a mean of 71 and a standard deviation of 15. So I'm going to label this test 1. And the score, the data value, is a 92. The mean, and it didn't designate whether this is a sample or population, so we'll just use the sample mean, which is x bar. The mean is 71, and the standard deviation, S, is 15. So for test 2, we had a score of 688. So data value with a mean, x bar, of 493 and a standard deviation, S, of 150. Finding the z-score for each one, data value minus the mean divided by the standard deviation. For the second one, data value minus the mean divided by the standard deviation. And I keep saying that instead of the values because I'm hoping me saying that over and over will help you memorize this formula, because you do need to know this formula for exams. So the z-score for the first test is 1.4. The z-score for the second test is 1.3. So when asked which one is better, the first test with the score of 92 is actually the better test score in this case. So we'll write which one is better? Test 1 is better.